At around 11:25 inches the morning, on the 6th of September 2024, a freight train derailed while passing over a railway bridge in Audenshaw, in Greater Manchester. The bridge carried the railway across a public footpath. Of the 24 wagons making up the train, 9 were fully loaded and left the rails. The derailment caused serious damage to the track, the bridge structure, and several wagons. No injuries were reported, but the railway line at this location was closed for approximately 8 weeks while repairs were completed. The track on the bridge was constructed differently from standard railway track. Rather than being supported by sleepers embedded in ballast, the rails were mounted on timber bearers that ran along the length of the bridge. This arrangement, known as a longitudinal bearer system, relies on base plates and screws to maintain the correct spacing between the rails. The derailment began when the distance between the rails increased beyond safe limits. As the train crossed the bridge, the wheels on the right-hand side of a wagon dropped into the widening gap between the rails. This loss of support marked the initial derailment event. Investigators found that the widening of the track gauge occurred because screws securing the rail base plates to the timber bearers had fractured. Detailed examinations showed that these screws had been affected by fatigue damage, which had developed over time before the accident. Inspection of components recovered from the site revealed that similar screw failures had occurred previously at the same locations on the bridge. Records relating to inspection and maintenance activities confirmed that at least 3 earlier fatigue-related failures had been identified. However, many relevant records were unavailable, largely due to weaknesses in record-keeping practices within the local maintenance team. Vehicle dynamic simulations conducted during the investigation showed that the forces applied by passing trains were within the limits set by Network Rail standards. Despite this, fatigue assessments demonstrated that the screws used in this configuration had a limited service life. The expected lifespan of the screws was closely linked to the thickness of packing material installed between the base plates and the timber bearers. Analysis indicated that when packing thickness reached 20 millimeters or more, the likelihood of fatigue failure increased significantly. While Network Rail standards permit packing thicknesses of up to 30 millimeters, measurements taken at the derailment site recorded values of up to 34 millimeters. In the years leading up to the derailment, the rate of screw failures had increased, coinciding with higher levels of rail traffic over the bridge. The investigation concluded that these factors combined to reduce the ability of the track to maintain proper gauge under load. Following the investigation, 8 recommendations were issued to Network Rail. These addressed the design and assurance of longitudinal bearer systems, the competence of those responsible for maintaining them, and the coordination between teams managing track and bridge assets. Further recommendations focused on understanding how bridge condition influences track behavior, assessing the impact of traffic changes, improving asset record management, and strengthening inspection and maintenance assurance processes. Because understanding how failures develop is essential, it's the first step toward preventing them from happening again.